And we've been doing several stack videos. And several of my videos before that were stack, and it's because a stack is very important to understand. It's a very basic concept. People kind of understand it, but the details of some of these things remain a mystery. So, you know, for beginners and things like that. So here we are, our last stack video. And in this video, it's going to be extremely simple application. First of all, I'm not going to complicate it with trying to keep these functions that I'm going to create from being inlined, because I've looked up the prefix to create them from being inlined from the compiler instead of exporting them from the executable and things like that, which I just did on the fly because I just didn't look up a way to do it. So this time I did it so I don't have to do all that crap. And I also did not want to turn on debug or turn off optimizations. I want everything else to still be the same. So what we're going to do today is I've already created this sources file. So there's nothing else here. The sources file is how you build it. So I'm just going to build main. It's going to be console app. That's pretty much it. So let's take this, open up my editor, which is Visual Slick Edit, and start creating this program. So we'll do stdio. So now I'm going to create two functions. And so how to do, you just do no inline with decal spec. So function one is going to be read a string, very simple. And this is not going to take any input, not going to provide any output. The next is also going to be similar, where I don't take any input or output. It's going to be called output a string, very simple. Now, then I'm going to do the int main and just do read a string, output a string, return 0. And I'm actually not even going to do these prototypes. I'm just going to code them up here. So, unfortunately, can't use gets these days anymore. Because a lot of time it's not secure. So you use gets underscore s or something like that. So I'm just going to use fgets. And so as we're going to see here, I'm just going to read in a string, read in input string, and we'll just do 256 here. And so I'll put input string here, 256 stdin. That's it. And then we return. So technically, should be gone right from the stack. Now we're going to come down here and do char sc. Let's see, stack input, and I could change this to something else. I could change it to ulong, ulong 64. Doesn't really matter. But I'll do it the same. So what this means is that if I call this function here, and the same exact parameters are set up, it'll read this into the stack location. If I then call this function, and the same exact stack frame is set up again, then the sc stack input will be in the same place as sc input string was in the previous function call. What does that mean? Well, also that means that I can just print it out from this function. So I'm also going to do it this way instead of doing the %s or whatever like that, because I want to continue to show people that you don't need to have a format string here. You can just pass in any string you want. That's it. This is the entire function. Now again, this is not right programming, not passing anything between them. So what we're going to do, we need to compile it. See if there's a compile. Yep, it compiles. Okay, so we of course are going to come in here. Hey, how slow this thing is. So anyhow, as you can see, it does call read a string and output string. So let's unassemble read a string. Okay, so read a string is going to call fgets. It is subtracting a big chunk of memory from the stack there. It then let's see, where is RCX? RCX does that, so that's the location on the stack where the string will start. And of course it is, at the bottom of our SP plus 32, because we do have 4 reserved parameter locations, and so we've reserved a certain amount of memory above that. So what is 138? So it's 312 bytes that have been reserved. And so now let's check out one other thing. So we know where the string is. It's at RSP plus 20 hex, and we only subtract by 312. So let's check this out. Sorry. Oh, we subtract by 138. We subtract by 138. Now, when we do printf, we pass in as the first parameter, at least ACX RSP plus 20. There you go. So it will pass in the exact same location because we subtract the same. We are the same. We're at the same stack level when we come in to both these functions. We are passing in the same thing here. And 32-bit, you can get into an iffy situation because, they don't necessarily need to clean up the stack right away. They can do some optimizations here and there. They could add more to the stack. I mean, most likely it's going to work because we did void parameters, but, it's more guaranteed here on the 64-bit. So now we can actually take a look at this here. So let's set a breakpoint here. Okay, so now we got to type in string. Here is a string, period. Okay, now we're at this place here. Now if I do DC RSP, you can see on the stack, my string's not there. Right? Now, if we subtract 138, I mean, there's going to be one more, something I could do plus 8, but who cares? So if I do that, DQS up, right? Then I do the same thing, but instead I do DC. Look, there it is. Here is a string. So if I come in here, I do this, do this, do this, do this. Yep, now RSP plus 20. You can do DA on that. Let's just see what it looks like. Here's a string. Okay. So there you go. Here's a string. Quit. Okay, so now let's just do it without the debugger. Okay, here is my string. Yeah, whatever. Prints it back out again. All right, next line. All right. Here. Yeah. So that's it. Very, very simple. Took like 2 seconds to do this thing. So again, we're playing around with the stack here because we've read it in. One function call right in it. Didn't pass it to the next function call, but the next function call still was able to print it because it's still sitting there. And as long as you can get the same stack frame like we did here, you can see it. But again, this isn't something that you actually want to do in real programming. This was just a fun thing to show you in a real simple, because last time I think the example may have been more complex than I thought it would be. But this one's a very, very simple example. Shows you that you can make a function call, and when you make another function call, that data, it's still left on the stack. It's not cleaned up. So that's why if you don't initialize your variable, you don't know what garbage you're going to have in your variable. As you can see, in this case here, the garbage that I had in my variable was the data read into that location from the previous function call. So that is why they tell you to initialize your variables. Right? So, yeah, hope you enjoyed something, had a little fun with this thing. Again, this is this is a simpler exercise, I guess, than the last one.